Okay. Good afternoon to one and all. So, in the previous lecture, we have concluded the unit number 3, that is the testing of DC machine. So, in case of testing of DC machine, we have discussed different types of tests like direct and indirect method of testing. Again, we have discussed regarding Swinburne test. We have discussed regarding Hopkinson test. Also, we have solved some problem related to that. Okay. So see, today we will start the next one section, that is section second. This section second, it will contain 2 units. This totally depends upon transformer. So in this section, unit number 4, that is first unit, section second matlab first unit, and subject matlab fourth unit. Unit number 4 is that the single phase transformer, and fifth one unit is that 3-phase transformer. So this include this will be these 2 units, it will be included in the section second. So in this case, that is in case of single phase transformer and 3-phase transformer. So first of all, we will see the unit number 4. After that, we will start the unit number 5. See, unit number 4 is that the single phase transformer. So we will discuss regarding first of all the syllabus of that unit, that means content which are included in that unit, and we will see one by one each and every content. Okay. See, this unit, it will be include the transformer construction and its types. That means it is most important point. That is transformer construction and its types. How the transformer it can be constructed, what type of material it can be used, and what are the types of that single phase transformer. Okay, right? Single phase transformer types. After that, we will discuss regarding EMF equation, that is EMF equation of transformer. You people already studied this one in the diploma, as well as you are in the first year. At that time, you have already studied the transformer construction, types of transformer, and what is the EMF equation. After that, the unit content, the voltage ratio, then kVA rating, then transformer condition, that is transformer on no load condition and transformer on load condition. Okay, load condition la transformer, and no load condition transformer. Transformer on load condition and the transformer on no load condition. After that, the losses and efficiency with its phasor diagram. Condition for maximum efficiency, what is the condition we have already derived in case of DC generator and motor. What is the condition for to get the maximum efficiency in case of transformer? Also we want to discuss what is the condition for maximum efficiency. Then transformer equivalent circuit and the effect of load on the power factor. That means, do you know that there are some types of load like resistive load, inductive load, or it may be capacitive load. So different types of load is there. So according to this, what is the effect of that load on the power factor? Power factor, that's a high effect. Then some of the testing, that is polarity test, we have discussed in case of open circuit test and short circuit test. Then the parallel operation of transformer, that is parallel operation, why the transformer it is parallelly operated, what is the necessity, what are the condition for operating 2 or more than 2 transformer in parallel. So these are this we will be discussing the parallel operation. And the last one point of this unit, it is nothing but auto transformer. So what is the auto transformer, what are the types of auto transformer, and one derivation related to auto transformer, that is saving of copper in case of auto transformer. So this point we want to discuss in this unit, that is single phase transformer. Single phase transformer मध्ये हे आपल्याला काय करायचे, डिस्कस करायचे. Now we will discuss the first one point, is that transformer construction and its working principle. So before discussing regarding construction and working principle, we will discuss what is the transformer. Can anyone tell me the definition? Because you people already know. What is meant by transformer? Definition. A transformer definition. Can anyone able to tell definition of the transformer? What is the definition of the transformer? Transfer current one circuit to another circuit. Okay. Only it will transfer current or voltage, or it may be power. Okay, power. See, transformer, it is one device. It will transfer a power from one circuit to another circuit. So the power, it will be transferred from one circuit to another circuit in case of transformer. Whether this power, it may be constant or variable. Can anyone tell? Whether the power, it will be changed, or it may be it will remains constant. Either it may be step down transformer, or it may be step up transformer. There are some types of transformer like a step up transformer or a step down transformer. So the power remains same, or it may be there is a change in some power. Can anyone? Change in power. Okay, we will discuss definition. First of all of you understand the definition. The transformer, it is a static device. The transformer, it is a static device. Whether transformer, it will contain any rotating part? Anyone?
No.
No. So that we can call it as a transformer. It is a static device. Okay, that means there is no any rotating part. In case of DC machine like generator, or it may be motor, there are some of the rotating part will be there. So in case of transformer, it is a static device. It will transfer a power from one circuit to another circuit. It will transfer a power from one circuit to another circuit with change in its voltage and current, but without change in its frequency. What is the definition? All of you keep in mind. Definition of the transformer is that the transformer, it is a static device. Transformer, it is a static device. It can transfer a power from one circuit to another circuit, one circuit to another circuit with change in its voltage or current, but without change in its frequency. Right? It will change, either it may be voltage or it may be current, but without change in its frequency. Now see, suppose in case of step-up transformer, the voltage at the primary side, suppose it is 11 kV. That means 11,000 volt. 11,000 volt. And there is a step-down transformer, like it will be step down at 440 volt. Okay, it will be step down at 440 volt. See, input to that of transformer, it is nothing but 11,000. Output to that of transformer, it is nothing but 440 volt. This is the voltage. Whether it is step up or step down, voltage step up करते हो का step down करते हो अपन?
Step down.
Step down के लिए. Okay. Then what is the change in its power? Power मध्ये काय change होईल? What is the change in its power? Whether it will be same, or it may be there is a change, or power it is also step down.
Change the power.
Yes.
Change the power.
Change the power. Okay. See, for that purpose, understood the definition. Transformer, it is a static device. It will transfer a power from one circuit to another circuit with change in its voltage or current, but without change in its frequency. काय होतंय, voltage किंवा current change होतोय, but without change in its frequency. Frequency remains constant. Along with that, the power supplied, it is also constant. Okay, that means there is a some accepting some drop, or it may be some of the losses. The transformer power remains constant. See, another one definition is that the transformer, it is a static device which can transfer a power from one circuit to another circuit with increase in voltage and a decrease in current, or decrease in current, sorry, or decrease in voltage with increase in current. म्हणजे जर voltage decrease होत असेल तर current increase will, and if the current it will be increases, that means voltage it will be decreases, or voltage it will be increasing, then the current it will be decreasing. That means, so see, if here in case of step down transformer, it will decrease the voltage from 11,000 volt to 400 volt. In the same proportion, the current is increases on the secondary side. That means the power remains same. See, what is the definition? The transformer, it is a static device. It can transfer a power from one circuit to another circuit with increase in voltage and decrease in current, and vice versa. That means decrease in voltage and increase in current. Okay, जर voltage decrease होत असेल तर त्याचा current increase होतो, आणि जर current decrease होत असेल तर त्याचं voltage increase होतो. Right? No, that means according to step down मध्ये काय होईल, voltage decrease होत आहे, so the current at the output side it will be increases, so it will maintain the power remains constant on both sides. दोन्ही side ची power काय राहील, constant राहील. Okay, so similarly, if the step up transformer is there, so in case of step up, the output voltage it will be increasing. If the output voltage it will be increasing, that means current substantially decrease. Current काय होतो त्याचा decrease होतो. So keep in mind, so the product of phi into I, or the kVA rating phi into A, that is volt into current or volt into ampere, this ratio remains constant, right? So according to this, we are representing the transformer in the form of kVA rating. kVA rating च्या फॉर्म मध्ये आपण काय करतो, ट्रान्सफॉर्मर रिप्रेझेंट करतो. Okay, see, a definition: a transformer, it is a device which can convert magnetic energy into an electrical energy. It will convert the magnetic energy into an electrical energy, taking input as a electrical power. It consists of two coils called as a primary, and it will called as a secondary winding. The primary winding of the transformer, it will receive the power, and the secondary winding of the transformer, it will deliver the power. Okay, and a magnetic iron circuit called the core, it is commonly used to wrap, and this coil, though these two coils are electrically isolated and they are magnetically linked. Okay, so this is just introduction, it can be given. So transformer, we will discuss it in detail in the construction. That is, transformer, it is a static device which can convert electrical power, or it may be which can transfer a electrical power from one circuit to another circuit with the change in its voltage or current, but without change in its frequency. Frequency change na hota te काय करतो, transfer. See, the transformer, it will contain a two coil. Okay, it will contain a two coil, and if these two coils are kept nearer to each other, then there is a self-induced EMF, and the mutual induced EMF will be present in that coil. You people already know, if these two coils are magnetically coupled to each other, these are not electrically connected to each other, but it is magnetically coupled to each other. If these two coils are magnetically coupled to each other, at that situation, voltage given to one coil, then there is a, on the second coil, there is a EMF, it will be induces. So we will discuss that. See, it will contain a two coil. Okay, दोन coil असतात, one coil it is called as primary, another coil it is called as secondary. त्याला आपण primary coil किंवा secondary coil. Okay, all of you getting definition of the transformer? Yes, give me reply.
Yes.
Yes, sir.
Okay, now principle of working, that means on which principle the transformer it will be works. कोणत्या principle वरती transformer काय करतं, work करतं. Okay, can anyone tell me the principle on which principle the transformer it will be work? कोणत्या principle वरती work करतं?
Faraday's law of electromagnetic induction.
Faraday's law of electromagnetic induction. So, or we can call it as a, typically we can call it as a mutual induction principle. Okay, right now mutual induction principle. The transformer it will be works on the principle of mutual induction principle. Mutual induction principle वरती काय करतं, work करतं. So what is mutual induction principle? Can anyone? You people already studied that part. काय statement किंवा कसं work करतं ते? Anyone? No one. Okay. I will tell the mutual induction principle. See, there are two coils. That means in case of transformer, there are two coil. First one coil and second one coil. Suppose I will drawing here, that is coil. This one is the one of the core. We can say it is one core, iron core. On that core, there are some coil. It can be wound. So this one is the first coil. Okay. Similarly, this coil it can be wound on the core, and similarly another one coil it can be wound on the another core. Okay. See, here it is. I am applying a supply voltage P, and here I am attaching one of the voltmeter to measure the voltage. Okay. See, this one is the coil 1. Coil 1, and this one is the coil 2nd. Okay, see, this one is the coil 1 and this one is the coil 2nd. We are discussing regarding working principle of single phase transformer. See, if the two coils in case of transformer, first one coil we can call it as a primary winding. So second coil it is called as a secondary winding. So what is coil? Coil is nothing but one conductor. It can be wound, that is magnetical coil, that is copper wire. It can be wound on the iron core, or it will make a one coil. Okay, as we know that in our so this coil it can be coated. There are some of the varnish coating it can be done. So these are insulated, or it may be these are isolated from the core or insulated from the core also. Okay, so these are the coil. Coil it can be wound on that core. The core varti coil kai kelle wound kelle. So it will form a one coil, that is primary coil and secondary coil. Okay, do you know that if our cable, you people know the cable, there are coating of coating it can be provided to prevent the shock. That means wire असते आपली wire. If we have make a one coil or the wire जर आपण अशी गुंडाळून ठेवली, okay, or wind करून ठेवली, what will happen? काय होतं? Anyone? बघा, if we are connecting one cable, एक केबल आहे बघा आपल्याकडे. Suppose I am connecting, I am bringing one cable near about 100 feet cable I am bringing, and I required only 50 feet. Okay, so remaining 50 feet, that means instead of cutting that cable, I am totally connected to cable to that line. त्या लाईनला मी काय केली, केबल कनेक्ट केली, and the remaining cable I will wind off like that, किंवा मी त्या केबलचा एक गुंडाळा करून ठेवला. ओके, वाइंड करून ठेवली, and this end it can be connected to one of the motor, and this end it is connected to supply lines. What will happen if the cable, it will be wound some part here, or it may be some point it is wound, it will form a one coil. What will happen when the current it will be flowing from that coil? काय होतं रे? कॉइल मध्ये ईएमएफ इंड्यूस होतो? नाही नाही, आय एम स्पेसिफिकली आस्किंग अबाउट दिस. आपण जो केबलचा बंडल घेतो, सपोज शिल्लक राहती केबल, एक 10 फूट केबल शिल्लक राहते, मी गुंडाळून ठेवली आणि ती लाईनला कनेक्ट केले. व्हॉट विल हॅपन? शिल्लक केबल असेल तर आपण अशी काय करतो, अशी स्कॅटर्ड करून म्हणजे पसरून टाकतो. गुंडाळून ठेवली तर काय होतं? कॅन एनीवन? केबल बस्ट होते का? हॅलो, केबल बस्ट होते? Okay, see, if I wound the cable, or it may be if I rounded that cable at one specific point, at that situation when the current it will be start flowing from that coil, the air between that cable, it will be get ionized. That means there is a some flux it will be created, and two part of that cable it will be short circuited. दोन त्या केबलचे जे काय दोन पार्ट असतील ते शॉर्ट सर्किट होतात, so that the cable it will get burn. Okay, that means there is a flux it will be created. Due to that flux, because of that flux, it will induces some of the current around that cable. So air gap between that cable to round of the cable, this get ionized, and due to that there is a sparking it will be happen, and the cable it will be get burst. Cable काय होते? Burst होते. Okay, because of the insulated part, जे दोन केबलचे जे काही वरचे कोटिंग असतात, सपोज ते एकमेकांना चिटकलेले आहेत. ओके, like that, when the current it will be start flowing from that coil, due to current it will be flowing, there is some of the magnetic flux it will be created. Due to that magnetic flux, it will induces some of the EMF, and due to that EMF, the current start flowing in the air gap between that cable, two part of the cable. Due to that, the cable it will be get burst. Okay, like that. Similarly, if the two coils, we will discussing regarding principle. In case of two coil, these two coils are magnetically coupled to each other, but it is not electrically connected to each other. Okay, whether it is electrically connected, बघा मी कॉइल ड्रॉ केले, एक कॉइल इथं आहे, this one is the first one coil, and this one is the second coil. Whether these two coils are electrically connected? हॅलो, या दोन कॉइल इलेक्ट्रिकली कनेक्टेड आहेत का? Just give me reply. These two coils are not electrically connected. So here sentence is given, though these two coils are electrically isolated. This is the MCQ question. See, the transformer having an two coil, or we are considering what is the mutual induction principle I am telling. So in case of mutual induction principle, if two coils, that is coil 1 and coil 2, these are not electrically connected, but these are magnetically coupled to each other. Okay, the दोन coil electrically connected nahi hai, but it is magnetically coupled to each other. Okay, suppose this will be combined in one of the core, or it may be one transformer. there is no electrical connection between coil 1 and 2, but these are magnetically coupled. Okay, magnetically coupled to each other. So see, they are magnetically linked. Magnetically काय असतात त्या link असतात. Now see, when the supply is provided to one coil, what will happen? Supply मी काय केलं, एका coil ला supply दिला. That means when voltage it can be applied to one coil, at that situation some of the current it will be start flowing from that coil. या कॉइल मधून काय होईल, काहीतरी करंट फ्लो होईल. ओके, when the current it will be start flowing from that coil, at that situation it will induce some of the flux, right? जर एखाद्या कॉइल मधून कॉपर वायर मधून वुंड केलेल्या कॉपर वायर मधून जर करंट फ्लो झाला, व्हॉट विल हॅपन? काय होतं करंट फ्लो झाल्यानंतर? I have already tell no, now only
EMF induced.
First of all, flux phi it will be generated, or it may be flux phi it will be created. Okay, so see, when the current it will be start flowing in the coil, at that situation flux phi it will be produced around this coil, or it may be around this coil 1. Okay, now see, this produced a flux. If this flux it will be produces, so do you know that the flux lines are passing from anywhere? So like that the flux, this produced flux it will be links to that of secondary coil also, right? हे जे काय प्रोड्यूस झालेले फ्लक्स आहेत, फर्स्ट कॉइल मध्ये प्रोड्यूस होणारे फ्लक्स सेकंड कॉइलशी पण काय होतात, लिंक होतात. ओके, सी, when the current start flowing from primary coil, or it may be first coil, then there is some current it will be start flowing from that coil. Due to that current it will produce some of the flux. Due to that flux it will produce an EMF. Do you know that there are two types of EMF, that is self-induced EMF and mutual induced EMF, right? No, self-induced, that means any coil, if the current start flowing from that coil, then there is a some of the EMF it will be induces, so that EMF it is called as self-induced EMF, right? Now see, this flux lines it will be passing from one coil to another coil. That means it will be travel in the air gap between these two coil. दोन कॉइलच्या मध्ये जो काही एअर गॅप असेल याच्यामधून ट्रॅव्हल होते. ओके, and this flux phi it will be links to the second coil, coil 2. Coil 2 ला फ्लक्स काय होतील, लिंक होतील. When the flux phi it will be links to the secondary coil, then due to that flux there is some EMF it will be induces in the secondary coil. Secondary coil मध्ये काय होईल, काहीतरी EMF induce होईल. That means this induced EMF it will be shown by this voltmeter. इथं जो आपण voltmeter कनेक्ट केलेला आहे, so this voltmeter it will be show some of the induced EMF in the secondary coil due to the primary current. Okay, now see, this is the mutual induced EMF in the secondary coil due to primary coil. Now when it will induce some of the EMF, this induced EMF, if the secondary circuit it is closed, then the sum of the current it will be start flowing from the secondary coil. या secondary coil मधून काहीतरी काय होतो, current flow व्हायला start होतो. That means suppose in the primary current flowing from is nothing but I1, in the secondary current flowing from it is nothing but I2. याच्यामधून काहीतरी current flow व्हायला start होईल. If the current flowing current it will be start flowing from the secondary coil, again this due to that current it will be induces some of the flux. याच्यामध्ये परत काहीतरी फ्लक्स काय होतील, इंड्यूस होतील. So see, this flux phi 2 it is nothing but the flux induced due to that of current 2, and if this flux it is linked to that of primary coil, परत हे फ्लक्स काय होतात, प्रायमरी कॉइल ला लिंक होतात, and it will induce some of the EMF in this primary coil. So this EMF it is called as mutually induced EMF. Okay, म्हणजे त्या कॉइल मध्ये प्रोड्यूस होणारा जो काही EMF असेल, so this EMF it will be induces on both way or two way. First one way it is nothing but self induced EMF, and the second one is nothing but mutual induced EMF. So self induced EMF is nothing but त्याच करंट मुळे प्रोड्यूस होणारा जो काय EMF असेल, it is called as self induced EMF, and the current it will EMF it will be produced due to another coil current. दुसऱ्या कॉइलच्या करंटच्या फ्लक्स मुळे त्याच्यामध्ये EMF इंड्यूस होतो. सो इट इज नथिंग बट म्युच्युअल इंड्यूस्ड EMF. सो सी, This mutual induction principle, that means when the we are giving supply to only one coil, एकाच coil ला आपण supply देतोय, that means when the supply it can be given to one coil, there is a induced EMF in the secondary coil. So this is called as mutual induction principle. This is nothing but mutual induction principle, and on that mutual induction principle the transformer it will works. Transformer काय करतं, mutual induction principle वरती work करतं. Okay, so all of you getting mutual induction principle? Hello, लक्षात आलं का? Give me reply.
Yes, sir.
See, we will see again in details. Okay, see, do you know that the transformer it is static device? It will transfer a electrical power from one circuit to another circuit, having an constant frequency, or it may be same frequency, and it will consist of two coil, that is primary coil and secondary coil. See here in this figure there are two coils it can be given. This one is the one coil, coil 1, this one is the second coil, which are wound on the same core. Core जो आहे त्या सेम कोर वरती काय केलेले, wound केलेले. So primary winding we can call it as a primary winding, we can call it as a secondary winding. याच्यामधली एक primary winding असेल, next one is nothing but secondary winding. Okay, now see, when the primary of the transformer it is connected to AC supply, here supply it can be provided to that of primary winding, and one of the voltmeter it can be connected to the secondary winding. Secondary winding like voltmeter connect केलेलं आहे, primary winding it is connected to supply. When the supply it can be connected to primary winding, at that situation some of the current it will be start flowing from primary winding. Okay, see, the current flows in the coil and the magnetic field it will be built up. When the current it will be start flowing from this coil, या coil मधून ज्या वेळेस current flow याला start होईल, due to that current it will produces some of the flux. That means it will produces some flux or magnetic field it will be created. Okay, magnetic field काय will create होईल. So now this condition, that means the magnetic field it will be built up. This condition it is called as mutual induction. Okay, and this current, this flow of current is as per Faraday's law of electromagnetic induction. हा जो काय current असेल, this is as per the Faraday's law of electromagnetic induction. As the current flowing from that coil it will be increases from 0 to maximum value, then the magnetic field produced by that current it will be also strengthened, or it may be it will also increases. Okay, जसं जसा current आपण increase करत जाऊ supply चा, then the magnetic field created by that coil it will be increases. So this magnetic field it will be passing from this closed iron path, or it may be this path. Okay, here it is given, that is magnetic flux phi. It will be flowing from this coil to this coil. When this flux it will be flowing from this coil, या coil मधून ज्यावेळेस flux flow होईल, at that situation it will induces some of the EMF in this secondary coil. या coil मध्ये काय होतो, काहीतरी EMF induce होतो, that is E, or we can represent it is E2. Here the E1 EMF it will be induces in the primary coil. Due to that primary current there is a secondary induced EMF with nothing but E2, and if the E2 it will be induces in the secondary coil, and if the secondary circuit it is closed, ज्यावेळेस secondary circuit close असेल, at that situation in the closed circuit it will set up some of the secondary current. त्याच्यामध्ये secondary current काय होतो, काहीतरी flow होतो. Due to that secondary current, again due to that secondary current, when this secondary current it will be flowing from this secondary coil, it will produces again some of the flux. ते काय करेल, काहीतरी flux produce करेल. So this flux is also traveling from this core. Path provided by core. Core is nothing but it is one iron path. It is provided to flow of core flux. This flux it will be travel from this secondary to primary. Again this current it will be induces some of the EMF in the primary coil. So this is the mutual induction. That means primary current मुळे secondary मध्ये EMF induce होतो. It is also mutual. secondary current मधून primary मध्ये EMF induce होतो, that means it is also mutual. So that we can call it as a mutual induction principle. Okay, mutual induction principle. And if we increase the current, then the magnetic field created by that coil, it will also increase. त्या coil ने create केलेली जी काय magnetic field असेल, it will also increases. Okay. Now this electromagnet, it will forms the magnetic lines of force, and it will expand outward from the coil, forming the path of magnetic flux, and the turns of the both winding get linked by the magnetic circuit. या दोन्ही winding च्या ज्या काही turns असतील, number of turns, it will be linked with each other, but magnetically, not electrically. Yeah? All of you keep in mind, these two coils are not electrically connected, these are magnetically coupled to each other. They are magnetically coupled astat, so that the magnetically coupled is nothing but magnetic flux linking between two coils. The दोन coil मध्ये magnetic flux linkage असतं. That means primary चा produce झालेला flux secondary ला link होतो, secondary चा produce झालेला flux primary ला link होतो. That means there is a linking between primary and secondary flux. That means there is a linking between magnetic flux, right? So there is a flux linked by the magnetic flux, and the strength of the magnetic field generated in the core, it will be depends upon how many number of turns in that winding. It is also depends upon number of turns. Do you know that if the turns increases, the flux production, it will be increases. If the turns decreases, the flux production, it will also decreases. Right now, I think you people already know that is the flux production or the value of phi, it should be depends upon number of turns, because we have already discussed in case of DC generator or motor, it is depends upon it will be depends upon current flowing. In case of speed control technique, if we are reducing the value of current flowing from field winding, that means there is a flux production, it will be reduces. And if the flux production, it will be reduces, then according to the simultaneously the speed of the motor, it will be increases. We have already discussed. That means if the current flowing from that coil, it will be increases, again the number of turns, it will be increases, then automatically the field strength, or it may be magnetic field creation, it will be more. Magnetic field creation काय असेल? More असेल. Okay. See, it will be depends upon number of turns in the winding and the amount of current passed. Okay. किती amount चा current pass होतोय आणि किती number of turns आहेत त्याच्यावरती डिपेंड्स असेल की how much flux it will be created or how the flux it will be strengthened. Flux ची strength किती आहे हे त्याच्यावरती डिपेंड आहे. Okay. Now see, the magnetic flux and the current are directly proportional to each other. Do you know that? The current and flux, it will be directly proportional. As the current increases, the flux production, it will be increases. As the current decreases, the flux production, it will be decreases. Okay, flux production काय होतं? Decrease होतं if the current increases, and if the current decreases, and if the current increases, the flux production, it will also increases. Flux production, it will be also increases. Okay. Now there is a direct relation between we have already discussed in case of DC machine, that is ISH or field winding current, it is directly proportional to flux production. Similarly, the current flowing from coil, it is directly proportional to the flux produced, that is phi. Okay, it is directly proportional to flux. Now see, as the magnetic lines of force, as the magnetic lines of force or the magnetic lines of flux flow around the core, हा जो काय create होणारा flux आहे, if it is flowing around the core or path provided by the core, when it passes through the it will passes through the secondary winding, when it will be passes through the secondary winding, at that situation this flux, it will be links with that of secondary winding. Secondary winding ला तो flux काय होतो? Link होतो. If this flux, it will be links to that of secondary coil, it will induces some of the EMF like E2 EMF. It will be induces in the secondary coil. Secondary coil मध्ये काय होईल, काहीतरी EMF induce होईल, that is E2 EMF. It will be induces in the secondary coil, and due to that induced EMF there is some voltage across secondary coil. Secondary coil ला काहीतरी काय असेल, voltage असेल. And the Faraday's law, it is used to determine the value of voltage. That means how much voltage it can be induces in the secondary coil. This can be determined by using a Faraday's law. So do you know that the Faraday's second law? Second law, can anyone tell me Faraday's law of electromagnetic induction? Second law. Hello. Faraday's law of electromagnetic induction, there are two laws, first one and second one. Can anyone tell me the second one law? Hello.
The induced EMF is equal to rate of change of flux linkage.
Okay, right. That means the induced EMF, it is directly proportional to the rate of change of flux, right? So that means E is directly proportional. Induced EMF, suppose we are representing E is directly proportional to rate of change of flux. That means ज्या rate न flux change होईल त्या rate न induced EMF change होईल. That is d phi by dt, rate of change of flux. So E is directly proportional to d phi by dt. So we are able to write this is equals to E is equals to n d phi by dt, where n is nothing but number of turns of that coil, where flux phi is nothing but the flux produced in that coil, and the t is nothing but at what time, that means time. Okay, so see, E is equals to n d phi by dt. According to this equation, we are calculating how much EMF it will be induces in that secondary coil. Secondary coil मध्ये किती EMF induce होतो. So this can be calculated by using this equation. E is equals to n d phi by dt, where n is nothing but number of turns of the coil. Coil ला किती number of turns आहेत, म्हणजे किती wind केलेले, किती turns घेतलेले आहेत, number of turns of the coil. Then do you know that the frequency, as according to definition of the transformer, the frequency of the transformer remains same. That is, frequency is the same in the primary and secondary winding. Thus, we can say that the voltage induced in the same in both the winding. Okay, if the voltage it will be induces in the same in the both the winding, as the same magnetic flux it will be link both the coil together. Also, the total voltage induced is directly proportional to number of turns in the coil. Okay, so see, if we are considering equal kVA rating, or it may be if we are considering the same kVA rating, then, or we are considering the ideal transformer. So in case of ideal transformer, there is a no loss, or it may be it is the minimum loss. Or we can consider in case of ideal, meaning of ideal is nothing but there is a no loss, no losses of the transformer. It is nothing but the input power, it is exactly equal to that of output power. That means there is a, when there is a no losses. Okay, or we can call it as a constant loss. At that situation, if the flux linking to the both coil it is same, if the flux linking to the both coil, that is primary winding and secondary winding, it will be same. If the flux linkage it will be same, then EMF induction it will be same, or it may be induced EMF it will be same. If the induced EMF it will be same, we can call it as a equal kVA rating transformer, or it may be same kVA rating, or kVA rating of the transformer it is nothing but 1, like that. So kVA or transformation ratio we are representing, that is E2 divided by E1, E2 divided by E1, it is equals to V2 divided by V1, it is equals to number of turns N2 divided by N1, it is equals to K. This is the transformation ratio. So if E2 divided by E1, that means induced EMF in the secondary and the induced EMF in the primary, if it is same in case of ideal transformer, then we get the transformation ratio K is equals to 1, right? जर A2 आणि E1 सेम असेल आणि त्याचा रेशो काय येईल मग 1 येईल ना.
Yes, sir.
हा, that means we can call it as a transformation ratio of the transformer remains 1 or it may be equal kVA rating. kVA rating काय असेल equal असेल. Okay, so see like that this is called as a transformation ratio. If we are assuming the flux linked to the coil it remains same, दोन्ही coil ला link होणारा flux same आहे, and if the flux linking to that of coil remains same, so the induced EMF in the both the coil, that is primary and secondary, it will be same. If the induced EMF it will be same, then the voltage induced in the secondary side or the output voltage obtained in the secondary side, it is nearly equal to the primary applied voltage in case of ideal transformer. Then the transformation ratio of the transformer it will comes as a 1, is equals to 1, or it is comes as a 1. So this induced is directly proportional to the number of turns. That means number of turns N2 divided by N1. If N2 divided by N1 it is equals to 1, or it may be N2 and N1 are equal. N1 म्हणजे primary number of turns and the secondary number of turns या दोन्ही same आहेत, or it is equal. That means again ratio N2 divided by N1 it is equals to 1. That is transformation ratio. So this is directly proportional to induced EMF. ते induced EMF ला किंवा output voltage ला काय असेल direct proportion असेल. So this is one of the sentence related to that. So this is nothing but the working principle of the transformer. Working principle of the transformer, that is transformer it will work on the principle of transformer, it will be works on the principle of mutual induction principle. Again it is depends upon Faraday's law of electromagnetic induction. In the transformer working principle there are two coils it can be used. One coil it is called as primary winding, second coil it is called as secondary winding. So see, these two coils are not electrically connected to each other, but it is magnetically coupled to each other. Okay, त्या दोन coil ज्या आहेत त्या magnetically coupled असतात. And when the supply it can be given to one coil, there is a mutual induction it will be happen. That means according to mutual induction principle there is some of the EMF it will be induces in the secondary coil. Secondary coil मध्ये काहीतरी EMF काय होतो induce होतो. So this EMF it will be induces in the secondary coil due to mutual induction principle, or it is induced due to mutually. So that we can call it as a mutual induction principle. Okay. So this is related to working principle of transformer. In working principle of transformer, I have tell to you that is definition of the transformer, working principle, and how the EMF it will be induces in the transformer. So just it is the power transfer circuit from one circuit to another circuit. The power it will be transferred from one to another. पहिल्या सर्किट पासून दुसऱ्या सर्किट कडे पॉवर काय केली जाते ट्रान्सफर केली जाते. So that we can call it as a transformer. Whether there is any rotating device it will be present. Any rotating device आहे का present?
No, sir.
No.
So there is a no rotating device. So that we can call it as a static transformer. That is, it is one of the static device. And in electrical, this is only one device. In electrical, this one is the only one device. It is having an static device. All other devices are dynamically device. Right now, that means all other device it will contains one of the rotating part. Right. So in electrical, there is only one device, that is transformer. It is a static device. So in the definition, that word is that the transformer it is a static device which can transfer a power from one circuit to another circuit with change in its voltage or current. त्याचा voltage किंवा current change होतो, but without change in its frequency. त्याची frequency कधी change होत नाही. Okay, so that means we are maintaining the frequency remains constant. We are maintaining the frequency constant. We are changing voltage or it may be current. If the step up transformer is there, so in case of step up transformer, the voltage it will be secondary voltage it will be increases. So secondary voltage it will be increases. That means current on the secondary side it will be decreases. So that means the power again remains same. So निश्चित काय power असेल it will be same. So according to definition, with increase in voltage and decrease in current, or increase in current, that means decrease in voltage, that is vice versa. Okay, so it will transfer a power from one circuit to another circuit, and it will work on the principle of mutual induction. Mutual induction principle वरती work करतो. Okay, getting? Is there any doubt याच्यामध्ये? Hello.
No, sir.
Anyone? Any doubt? Niner?
No, sir.
Okay. So in this way, we will conclude this today's lecture, and we will stop here. Just 1 minute. I want to take attendance.